Hi, everyone. My name is Thom. I'm the Vice President of Product Management at DWave Systems. I'm excited to be here today to talk to you about DWave Systems and what we provide. I think the first place I want to start is just begin at the beginning here. What is a quantum computer? If we think about the computers in our everyday life, like our laptops and our phones, if you reach in and you pull out the computing chip in there, that's what's doing the information processing for you in a computer. And if you go into that chip, that CPU or GPU, and change its fundamental building blocks so that they can now behave quantum mechanically, but more importantly, behave quantum mechanically in a way where that's going to accelerate your information processing, you've just made that a quantum computer. And in that way, that's different than any other computer that's on the planet. Okay, so fair enough. If we give them quantum mechanical properties, how are we actually going to use that to accelerate information processing? So there's two principal ways. One is that you can use those quantum states to store more information in your computer memory and to process over that. And that's fantastic. That's called the gate model of quantum computing. It enables some very powerful algorithms. It also has some sensitivities. If the quantum state collapses, it can actually destroy that information, which is part of the reason why we have error correction schemes for recovering it. There's another mode for using the quantum mechanics to help accelerate information processing, which is to use the quantum mechanics to move through solutions quickly. And this is usually referred to as the quantum annealing model. The great thing about this is that if the quantum state collapses, the movement between solutions will pause, but after the end of the pause, the quantum state will reemerge and you'll continue moving through solutions. So both of these are ways that we can leverage quantum mechanics to accelerate information processing. And DWave is the only company building both types of technology because we want to be able to provide the technology necessary for your full quantum use cases. But having said that, this isn't about technology. The quantum computing industry is about helping businesses, governments, academics, and users to achieve their objectives more efficiently. So let's focus our conversation here about practical quantum computing and the ways that we can make use of it. Here's a compulsory legal slide. So at DWave Systems, we have the world's most powerful and connected quantum computers, the DWave Advantage systems with over 5,000 qubits and 15-way connectivity. And what's really different about these systems is that they're currently available in the cloud right now. And you can begin programming on them immediately and start working on getting demonstrations of application value for the applications that you're working on. We have a cloud platform with an integrated developer environment. We've got Python, open source Ocean tools that you can use for problem formulation as you're programming those systems, as well as a support site and user forums for you to collaborate with others. Now, through that LEAP system, you can make use of hybrid solvers. And this is not about hybridizing and looking at the way that quantum computers use. This is about achieving more results at application scale quickly. In these cases, when you're programming these systems, they actually deploy classical computers in the cloud that start working across this full application scale problem, breaking out pieces, submitting them to the quantum computer, and then reincorporating them in the solution. So it's a very powerful mechanism to allow you to get to up to 1 million variables for some binary quadratic model formulations, or if you're working with problems with constraints, up to 100,000 constraints, really enabling you to get to like enterprise scale application problems and demonstrations of real value. We get asked, are people using these systems right now? Absolutely, they are. Here's a selection of a series of customers in different sectors, the types of applications that they're looking at, and the phases of that development that they're going through. So typically beginning with application evaluation, looking for the places in their business where quantum computing technology could disrupt and provide big advantages for them, developing to proof of concepts at application scale that then move to a pilot deployments, and then to actual full production scale deployments, with some examples, for instance, being the development of new OLED materials and also protein design for medical therapeutics. Now, when I'm out speaking at developer conferences of people who are looking to program quantum computers and application, they sort of tell me, if I knew more about what a quantum computer could do, I'd be more interested in learning about the technology. Here's a set of examples with Menton that have done quantum design proteins that have been synthesized and taken to live virus testing against COVID-19. Save On Foods, which is using this for grocery optimization for their complicated business that includes ordering, at-home delivery, and brick-and-mortar store operations. They've been able to take some important grocery optimization problems from 25 hours down to 2 minutes. Denso has been looking at applications of optimizing their manufacturing floors, particularly the movement of autonomous vehicles, autonomously guided vehicles through the floor, and even optimizing for safety. They were able to demonstrate a 15% reduction in the time spent waiting for the movement of those vehicles, and OTI working on the OLED quantum chemistry examples. Now, I've got more here than we can possibly read or go through. This is just meant to be something as a reference to let you know what's possible here, but there's a number of companies who are working in financial services and data or portfolio optimization. We've also got examples here in manufacturing, logistics, and mobility. GrooveNots has actually done some really interesting work on optimizing waste collection vehicles in order to reduce CO2 emissions, so really important applications for sustainability. And Savantex has done some work optimizing operations at the Port of LA in order to make their throughput more efficient, which is a really important part as we're looking at applications to do with supply chain logistics changes and adapting to those and really allowing organizations to be more efficient and effective at what they're doing, as well as a variety of applications in life sciences, which is, of course, something that's really important to us with a variety of companies working through this. So I'll just pass over this briefly. This are the phases that we typically see businesses working through as they're looking to apply quantum computing to their applications. And I'd encourage you to check it out and follow up with us and find out more.